Welcome to today's episode, where we're diving into the fascinating world of log-structured storage systems, or LSS for short. We're going to explore how these systems are applied in LSM trees and SSDs, shedding light on the mechanisms that drive data management in our modern computing landscape. Along the way, we'll also discuss the innovative BW tree data structure and the emerging technology of open-channel SSDs. By the end of our conversation, you'll have a clearer picture of how these systems operate and what they mean for data storage and management. So let's start by understanding what log-structured storage systems really are. These systems are designed to optimize how data is written and retrieved. And the key to their performance lies in the idea of sequential writes. This approach minimizes the random access patterns that can slow down data retrieval, making it especially relevant when we look at LSM trees. These trees use a log-structured method to efficiently manage data. Now, how do LSM trees work? They organize data in a way that allows for rapid writing while also ensuring that reading remains efficient. They achieve this through a process called sequential compaction, where data is periodically merged and reorganized. This not only boosts write performance, but also consolidates data, making read operations smoother by reducing the number of locations where data is stored. However, LSM trees aren't without their challenges, particularly when it comes to concurrency, as multiple operations happen at the same time, like flushing data from memory to disk and performing garbage collection. Keeping data integrity intact becomes critical. It's essential that old mem tables, which temporarily hold data, remain accessible during these transitions. This requires careful coordination to prevent data loss and maintain the overall performance of the system. Concurrency issues can really lead to inefficiencies, especially when multiple threads are trying to access or modify the same data. As we delve deeper into these challenges, it's important to highlight the need for robust mechanisms that allow for smooth operation without compromising data integrity. Now let's talk about the relationship between LSM trees and SSD technology. This connection is particularly interesting because SSDs are built to handle sequential write patterns effectively, which aligns perfectly with how LSM trees operate. By leveraging this synergy, systems can significantly reduce performance issues like write amplification, where the actual amount of data written exceeds the intended amount due to the way data is managed. But there's a caveat. Stacking multiple log-structured systems can lead to inefficiencies and fragmentation. As data is written and compacted across different layers, careful coordination is needed to optimize performance and ensure that the benefits of sequential writes are fully realized. Speaking of innovations, we can't overlook the BW tree, an exciting data structure that enhances the capabilities of log-structured storage subsystems. The BW tree is designed for dynamic growth while also maintaining efficient garbage collection processes. One of its standout features is its ability to consolidate multiple delta nodes into a single base node during garbage collection. This consolidation reduces space usage and minimizes read latency, making data retrieval faster and more efficient. The BW tree is a great example of how thoughtful architecture can lead to significant improvements in data management, proving that tightly coupled structures aren't always necessary for optimal performance. Now let's touch on the topic of garbage collection, which is a vital aspect of data management, especially in structures like BW trees. By effectively consolidating nodes, the BW tree minimizes the overhead of maintaining multiple versions of data. This strategy underscores the importance of efficient garbage collection in enhancing overall system performance. It's fascinating to see how thoughtful design choices can lead to substantial benefits in data management, allowing systems to achieve better performance without unnecessary complexity. As we continue our exploration, let's introduce the concept of open channel SSDs. This emerging technology allows for direct access to hardware, bypassing traditional software layers like file systems and flash translation layers. By cutting out these intermediaries, open channel SSDs provide better control over data management processes, including wear leveling and garbage collection. Implementations like LOX, or Lightweight Open Channel SSD, and LightNVM in the Linux kernel highlight the potential of open channel SSDs to streamline data management. These systems enable a more efficient use of storage resources, which translates to improved performance and longevity for SSDs. As we wrap up today's episode, we've taken a deep dive into the intricacies of log-structured storage systems, focusing on their applications in LSM trees and SSDs. We've discussed the challenges of concurrency, the synergy between LSM trees and SSD technology, and the innovative BW tree data structure. We also introduced the exciting concept of open channel SSDs and their potential to revolutionize data management. Understanding these concepts is crucial for anyone involved in modern computing environments, as they pave the way for optimizing data storage and management. Thank you for joining us today, and we hope you gained some valuable insights into the world of log-structured storage systems. Be sure to tune in for our next episode, where we'll continue exploring the latest advancements in data management technology.